Hi people, today I am going to explain about measurement of susceptibility by Gouy method. The apparatus required in this experiment is digital Gauss meter, constant power supply, electromagnetic field, scientific balance, weights and a sample rod of aluminium. First we should place a probe between the two poles at equidistance with the help of stab. Now, in constant current power supply, we will increase the value of current from 0 to 5 and we will take the reading in Gauss meter. By increasing the current, we got these values, and here the Gauss meter reading is considered as measured magnetic field. After taking down the values in Gauss meter, we have to remove this probe between these poles. To study Gouy method, we could use para, ferro or diamagnetic substance, and in this experiment we are using paramagnetic substance as example. So here we will take aluminum rod as example and we will place this to one side of the scientific balance. Now aluminum rod should be placed like this between two poles at equidistance. These poles are nothing but magnets, and again that is connected to the electric field, so this is called as electromagnetic field. Now again we will increase the value of current and we will measure the weight of the aluminum rod. Here we consider aluminum rod as paramagnetic. We all know that para will attract. So at zero current we will measure the weight of the aluminum rod by moving this screw. Now if you observe, the needle is going towards right side. That means we have to add weight to the right side of this scientific balance. Now I added 25 grams, let us measure. Again this is going right side, means we have to add little more weight. Like this we have to add weights. Now if you observe, after adding weights the needle is moved to the left side. That means we have added more weight. Now we should remove little weight. Now if you observe, the needle is at the middle. This is the exact weight of the aluminum rod. We will increase the current value till 5 and we will measure the weight of the aluminum rod. As we increase the current values, the weight of the aluminum rod changes in the milligrams only. The formula for susceptibility is given by X volume is equal to 2G by A into del M by H square, where G is the acceleration due to gravity, A is the area, del M is the change in the weight, M is the measured magnetic field. Here we considered aluminum rod as sample. So its width is 10 millimeters, length is 12 meters, thickness is 2 millimeters, weight of the rod is 6.5 grams, density of the aluminum is equal to 2.7 gm by cc, area is equal to 0.2 centimeter square, G is equal to 980 centimeter per second square. Now we will draw a graph between magnetic field square and change in the weight. We will take the magnetic field values along x-axis and change in weight values along z-axis. If we draw a graph, we will get a straight line, and Lm is nothing but the difference from the final point to the initial point. Here we are considering the Gauss meter reading in kilograms, so we will multiply the value with 1000. Here if you observe, we got a straight line, and from this we will take the slope values. And the slope values is y2 minus y1 by x2 minus x1, and here y2 is equal to 33 where our slope cuts, and y1 is at 0. From the graph we are substituting the values. We got these values from the graph. Y2 is equal to 33 and y1 is equal to 0, and here we are converting these grams into milligram, so we are dividing this with 1000, and x2 is equal to 200.7889 and x1 is equal to 0.1451, and here we are converting this kilogauss into milligauss. After calculating we will get this value. Now we are substituting the del m by h square value in susceptibility formula. 2 into we know that G is equal to 980 into del m by h square value. Now only we got 0.164 into 10 to the power of minus 1. We will substitute that and we know that area value is 0.2. By calculating, we will get the susceptibility volume value is equal to 1.607 into 10 to the power of 7. And here if you want susceptibility mass, means that is nothing but susceptibility volume by density, that is equal to 1.607 into 10 to the power of minus 6, and the value of density is 2.7 for aluminium. After getting that value, we will substitute the value in molar. By calculating, we will get this value, and for molar susceptibility, that formula is equal to susceptibility mass into molecular weight of aluminium dot. We know that weight of the aluminium is 27. By substituting that, we will get this value, and that's it, our experiment is done.